Welcome to Math with Miss J. Today we'll be answering this question: why do domain restrictions exist for even root functions and their inverses? Let's get started. First, let's recall how to find the inverse of a function. Switch x and y and solve for y. Then ask, does the original function pass the horizontal line test? If the answer is yes, you are done. The domain and range for both the original function and its inverse is all real numbers. If the answer is no, we've got some work to do. By the end of our chat, we'll discover what to do next. Linear functions are an example of a function whose domain does not need to be restricted for its inverse to be a function. It passes the horizontal line test. When we draw a horizontal line through the graph, it only hits once. If a function passes the HLT, its inverse is also a function. Here's the inverse of the linear function we just saw. Remember, the VLT or vertical line test is used to test whether or not a graph is a function. When we draw a vertical line through this graph, it only hits once, meaning that yes, this graph is a function. And remember, when we look at the graph of the original function and its inverse on the same coordinate plane, we can see that these graphs have an interesting relationship. The graph and its inverse will always be symmetric about the line y equals x. In summary, linear functions and any function that passes the horizontal line test will not need to have a domain restriction for its inverse to also be a function. The domain and range of both this original function and its inverse will always be all real numbers. Now let's explore a quadratic function. Looking at the graph of this function, we can immediately see that it fails the HLT, because when we draw a horizontal line through the graph, it hits twice. This tells us that as of right now, the inverse of this function will not itself be a function. Let's look at solving for the inverse. Switching x and y and then solving for y results in a square root function. Remember that as part of solving, when we take the square root of both sides, you do have two results, both the positive and the negative. That plus or minus actually indicates that we have two separate equations. We have the positive square root and we have the negative square root. Here, we see what this graph will look like if we graph both the positive and the negative on the same graph. Let's now compare both graphs. The original graph failed the horizontal line test. This told us that its inverse would not be a function, and we can see this to be true. The graph of the inverse that's on the right side here shows us it fails the vertical line test, meaning right now the inverse is not a function. By restricting the original quadratic function to just the positive half, we ensure that the inverse will be a function, because this means we will also only keep the positive half of the square root function. This allows the original function to pass the HLT and the inverse to pass the VLT. Or we could restrict the original quadratic to the negative half, meaning that the domain restriction will be x is less than or equal to the x value of the vertex. This also means we will choose to keep the negative half of the square root function. This allows the original function to pass the HLT and the inverse to pass the VLT. In conclusion, we will always have a domain restriction on the original quadratic function to ensure that the inverse will always be a function and pass the vertical line test, which means we will always end up either keeping the positive half of the square root function or the negative half of the square root function.